Are you looking to learn how to protect and secure your compute resources? How to leverage best AWS security practices in protecting those compute resources? Then this is the video for you guys. We will cover 6 best practices regarding the AWS security, how to protect your computing resources. We will cover things like performing vulnerability management, how to reduce your attack surface, how to implement managed services and automate compute protection. We will enable people to perform actions at a distance and validate software integrity. So compute resources include EC2 instances and containers, AWS Lambda functions, database services, IoT devices, and more. So each of these compute resource types requires different approach to secure them. However, they do share common strategies that you need to consider, such as defense in depth, vulnerability management, reduction in attack surface, automation of configuration and operation, and performing actions at a distance. We will cover the general guidance, how to protect your compute resources and services, how to secure them, and how to harden them. So this video is all dedicated in compute protection best practices. So let's dive straight into the first best practice. So the first best practice in protecting your compute resources is performing vulnerability management program. So we will cover tools such as Amazon Inspector, Amazon CodeGuru, Amazon Systems Manager, AWS Security Hub, and AWS CloudFormation. So it's very important to frequently scan and patch for vulnerabilities in your code, dependencies, and your infrastructure to help protect against threats. So our goal is to create and maintain a vulnerability management program, regularly scan and patch resources such as Amazon EC2 instances, Amazon Elastic Container Services such as Amazon ECS, Amazon Elastic Kubernetes Service such as Amazon EKS workloads, configure maintenance windows for AWS managed resources such as Amazon Relational Database, Amazon RDS, use static code scanning to inspect application source code for common issues, consider web application penetration testing in your organization with required skills, or hire outside of assistance. So most of organizations fail because they either don't have a vulnerability management program, they're not performing patching without considered severity or risk avoidance, they are using software that has passed its vendor provided end of life date, or they are deploying code into production before analyzing it for security issues. So how we can avoid those issues and how we can implement vulnerability management program. So a vulnerability management program includes security assessment, identifying issues, prioritizing and performing patch operations as part of resolving the issues. So automation is the key to continually scanning workloads for issues and unintended network exposure and performing remediation. So automating the creation and updating of resources saves time and reduces the risk of configuration errors, creating further issues. A well-designed vulnerability management program should also consider vulnerability testing during the development and deployment stages of the software lifecycle. Implementing vulnerability management during the development and deployment helps lessen the chance that vulnerability can make its way into your production environment. Implementing vulnerability management program requires a good understanding of the AWS shared responsibility model, which we covered in our first video, and how it relates to your specific workloads. Under the shared responsibility model, AWS is responsible for protecting the infrastructure of the AWS cloud. The infrastructure is composed of the hardware, software, networking, and the facilities that run AWS cloud services. You are responsible for security in the cloud. So for example, the actual data, security configuration, and management tasks of the EC2 instances, and verifying that your Amazon S3 objects are properly classified and configured. Your approach to vulnerability management also can vary depending on the services you consume. For example, AWS manages the patching for your managed relational database service, Amazon RDS, but you could be responsible for patching self-hosted databases. AWS has a range of services to help you with your vulnerability management program. Amazon Inspector continually scans AWS workloads for software issues and unintended network access. AWS Systems Manager, Patch Manager, helps manage patching across your Amazon EC2 instances. Amazon Inspector and Systems Manager can be viewed in AWS Security Hub, a cloud security posture management service that helps you automate AWS security checks and centralized security alerts. Amazon CodeGuru can help identify potential issues in Java and Python applications using static code analysis. So how do we implement that program? So we can start with Amazon Inspector. So Inspector automatically detects newly launched Amazon EC2 instances, Lambda functions, and eligible container images pushed to Amazon ECR, and immediately scans them for software issues, potential defects, and unintended network exposure. You can also scan libraries and dependencies for issues and defects. Using Amazon CodeGuru, you can scan and provide recommendations to remediating common security issues for both Java and Python applications. Also, the OWASP Foundation publishes a list of source code analysis tools, also known as SAS tools, so static application security testing. Also, it's very important to implement a mechanism to scan and patch your existing environment, as well as scanning as part of your CI/CD pipeline build process. So implementing a mechanism to scan and patch for issues in your dependencies and operating systems to help protect against new threats. Have that mechanism run over a regular basis. Security vulnerability management is essential to understand where you need to apply patches or address software issues. So prioritize remediation of potential security issues by embedding vulnerability assessment early into the continuous integration, continuous delivery pipeline. Your approach can vary based on the AWS services you are consuming. So to check for potential issues in software in Amazon EC2 instances, add Amazon Inspector to your pipeline to alert you and stop the build process if issues or potential defects are detected. Amazon Inspector continually monitors resources. You can also use an open source product such as OWASP Dependency Check, SNCC, OpenVAS, package managers, and AWS partner tools for vulnerability management. Also, use AWS Systems Manager. So you are responsible for patch management for your AWS resources, including Amazon Elastic Compute Cloud instances, also known as EC2, Amazon Machine Images, AMIs, and other compute resources. So AWS Systems Manager Patch Manager automates the process of patching managed instances with both security related and other types of updates. Patch Manager can be used to apply patches on Amazon EC2 instances for both operating systems and applications, including Microsoft applications, Windows Service Packs, and minor version updates for Linux-based instances. In order to Amazon EC2, Patch Manager can also be used to patch on-premise services. So for a list of supported operating systems, you can also view supported operating systems in the System Manager user guide. You can scan instances to see only a report of missing patches, or you can scan automatically and install all the missing patches. Also, use AWS Security Hub. So Security Hub provides a comprehensive view of your security state in AWS. It collects security data across multiple AWS services and provides those findings in a standardized format, allowing you to prioritize security findings across AWS services. And then lastly, use AWS CloudFormation. So CloudFormation is infrastructure as code service that can help you with vulnerability management by automating resource deployment and standardizing resource architecture across multiple accounts and environments. Amazon Inspector is a vulnerability management service that continually scans your AWS workloads for software vulnerabilities and unintended network exposure. So Amazon Inspector automatically discovers and scans running EC2 instances, container images, and Elastic Container Registry, and AWS Lambda functions for known software vulnerabilities and unintended network exposure. So Amazon Inspector creates a finding when it discovers a software vulnerability or network configuration issue. A finding describes a vulnerability, identifies the affected resource, rates the severity of the vulnerability, and provides remediation guidance. You can analyze findings using the Amazon Inspector console or view and process your findings through other AWS services. So let's dig deeper and cover most of the important Amazon Inspector features. So you can centrally manage multiple Amazon Inspector accounts. So if your AWS environment has multiple accounts, you can centrally manage your environment through a single account by using AWS organizations. Using this approach, you can designate an account as the delegated administrator account for Amazon Inspector. Amazon Inspector can be activated for your entire organization with a single click. Additionally, you can automate activating the service for future members whenever they join your organization. The Amazon Inspector delegated administrator account can manage findings data and certain settings for members of their organization. This includes viewing aggregated finding details for all member accounts, activating or deactivating scans for member accounts, and reviewing scan resources within AWS organization. You can also continually scan your environment for vulnerabilities and network exposure. So with the Amazon Inspector, you don't need to manually schedule or configure assessment scans. Amazon Inspector automatically discovers and begins scanning your eligible resources. Amazon Inspector continues to assess your environment throughout the life cycle of your resources by automatically rescanning resources in response to changes that could introduce a new vulnerability, such as installing a new package on EC2 instance, installing a patch, and when a new common vulnerabilities and exposures that impacts the resource is published. Unlike the traditional scanning software, Amazon Inspector has a minimal impact on the performance of your fleet. When vulnerabilities or open network paths are identified, Amazon Inspector will produce a finding that you can investigate. The finding includes comprehensive details about the vulnerability, the affected resource, and remediation recommendations. If you appropriately remediate a finding, Amazon Inspector automatically detects the remediation and closes the finding. You can also assess vulnerabilities accurately with Amazon Inspector Risk Score. So Amazon Inspector collects information about your environment through scans. It provides severity scores specifically tailored to your environment. Amazon Inspector examines the security metrics that compose the National Vulnerability Database score for vulnerability and adjust them according to your compute environment. So for example, the service may lower the Amazon Inspector score, a finding for an EC2 instance, if the vulnerability is exploitable over the network, but no open network path to the internet is available from that instance. The score is in CVSS format and is a modification of a base of common vulnerability scoring system provided by National Vulnerability Database. You can also identify high impact findings with the Amazon Inspector dashboard. So Amazon Inspector dashboard offers a high level view of findings across your environment. From the dashboard, you can access the granular details of a finding. The dashboard contains streamlined information about scan coverage in your environment, your most critical findings, and which resources have the most findings. The risk-based remediation panel in the Amazon Inspector dashboard presents the findings that affect the largest number of instances and images. This panel makes it easier to identify the findings with the greatest impact on your environment, review finding details, and review suggested solutions. You can also manage your findings using customizable views. In addition to the dashboard, Amazon Inspector Consoles offers a findings view. This page lists all the findings for your environment and provides the details of individual findings. You can view findings grouped by a category or vulnerability type. In each view, you can further customize your results using filters. You can also use filters to create suppression rules that hide unwanted findings from your views. You can use filters and suppression rules to generate finding reports that show all findings or a customized selection of findings. Reports can be generated in a CSV or JSON formats. You can also monitor and process findings with other services and systems. To support integration with other services and systems, Amazon Inspector publishes findings to Amazon EventBridge as finding events. EventBridge is a serverless event bus service that can route findings data to targets such as AWS Lambda functions, AWS Simple Notification Service, topics. With EventBridge, you can monitor and process findings in near real time or as part of your existing security and compliance workflows. If you have activated AWS Security Hub, then Amazon Inspector will also publish findings to the Security Hub. Security Hub is a service that provides a comprehensive view of your security posture across your AWS environment and helps you check your environment against security industry standards and best practices. With Security Hub, you can more easily monitor and process your findings as part of a broader analysis of your organization's security posture in AWS. So that's pretty much it on how we perform vulnerability management system. Let's jump into the second best practice. So how do we reduce attack surface? So when deploying Amazon Linux or Amazon Windows servers, it's very important to follow the best security guidance. So we have tools in our radar that we can use to secure those instances. One of the best tools is Center for Internet Security hardened images that we can deploy our compute instances. So Center for Internet Security publishes a number of hardened images for your Amazon and Windows machines. Doesn't matter whether it's your SQL machine, whether it's specific Ubuntu image, or any other specific kernel for Amazon. You can deploy Center for Internet Security hardened images to make sure that all the services that are unnecessary are removed from the image. So that's one way how we can reduce the attack surface on our compute instances. Secondly, we have to make sure that every single compute instance that we build, traffic to and from the machine is encrypted. Also, all of the disks that are attached to the machine are encrypted at rest. We also need to make sure how we configure access to those machines. So having robust firewall rules that only allow specific whitelisted IP addresses to access our machines. Unless your machine is serving public internet traffic, avoid using firewall rules that has an asterisk as a rule. So it basically means allowing everyone to access that machine. Only select specific whitelisted IP addresses and access to your machine. And thirdly, remember that when creating permissions for specific machines, you have to prioritize least privilege. So only people that need to perform administrative tasks can have access to underlying infrastructure for your compute instances. So these are the few best practices to follow in securing your compute instances. Obviously, we discussed, patch management is very important, or vulnerability management in securing those machines and making sure that we reduce the attack surface. But most of organizations nowadays are moving away from deploying infrastructure as a service, and everyone's moving towards, serverless compute instances, and most of the organizations are using AWS Lambda functions. So we'll dig a bit deeper on how we can secure AWS Lambda functions. So it's very important to separate the Lambda handler from your logic. This allows you to make a more unit testable function. Also, it's very important to take advantage of execution environment and reuse to improve the performance of your function. So initialize SDK clients and database connections outside of the function handler, and cache static assets locally in the TMP directory. Subsequent innovations processed by the same instance of your function can reuse these resources. This saves cost by reducing the function runtime. To avoid potential data leaks across invocations, don't use the execution environment to store user data, events, and other information with security implications. If your function relies on a mutable state that can't be stored in memory within the handler, consider creating a separate function or separate versions of the function for each user. Use a keep alive directive to maintain persistent connections. So Lambda purges idle connections over time. Attempting to reuse an idle connection when invoking a function will result in a connection error. So to maintain your persistent connection, use the keep alive directive associated with your runtime. So for example, you can see how you can deploy things like, keep alive in Node.js and things like that. Use environment variables to pass operational parameters to your function. So for example, if you're writing to an Amazon S3 bucket, instead of hard coding the bucket name, you are writing to configure the bucket name as an environment variable. Control the dependencies in your function deployment package. The AWS Lambda execution environment contains a number of libraries such as AWS SDK for the Node.js and Python runtimes. And to enable the latest set of features and security updates, Lambda will periodically update these libraries. These updates may introduce subtle changes to the behavior of your Lambda functions. To have full control of the dependencies of your function uses, package all your dependencies with your deployment package. Also, minimize package size to its runtime necessities. This will reduce the amount of time that it takes for your deployment package to be downloaded and unpacked ahead of invocation. For functions authored in Java or .NET Core, avoid uploading the entire AWS SDK library as part of your deployment package. Instead, selectively depend on the modules which pick up components of the SDK you need. Reduce the time it takes Lambda to unpack deployment packages. So authored in Java by putting your dependency.jar files in a separate /lib directory. This is faster than putting all your functions code in a single jar with a large number of class files. Also, minimize the complexity of your dependencies. Prefer simpler frameworks that load quickly an execution environment at the startup. So for example, prefer simpler Java dependencies injection frameworks like Dagger or Guide over more complex ones like Spring framework. Avoid using recursive code. So in your Lambda function, wherein the function automatically calls itself until some arbitrary criteria is met, this could lead to unintended volume of function invocations and escalated costs. If you do accidentally do so, set the function reserved concurrency to 0 immediately to throttle all invocations of the function while you update the code. Do not use non-documented, non-public APIs in your Lambda function. For AWS managed runtimes, Lambda periodically applies security and functional updates to Lambda's internal APIs. These internal API updates may be backwards compatible, leading to unintended consequences such as invocation failures if your function has dependency on these non-public APIs. So it's very important as well to perform testing of your Lambda function. So it's a crucial part of ensuring you pick the optimum memory size configuration. Any increase in memory size triggers an equivalent increase in CPU available to your function. Memory usage to your function is determined per invoke and can be viewed in Amazon CloudWatch. On each invoke report, entry will be made such as this. So it will report request ID, the duration, the build duration, the memory size, the memory used, as well as the memory used field. So to find the right memory configuration for your functions, we recommend using open source AWS Lambda Power Tuning project, which you can find on GitHub. Also, it's very important to load test your Lambda function. So to determine an optimum time of value, it is important to analyze how long your function runs so that you can better determine any problems with a dependency service that may increase the concurrency of the function beyond what you expect. This is especially important when your Lambda function may network calls to resources that may not handle Lambda scaling. Also, it's very important you most restrictive permissions when setting IAM policies. Understand the resources and operations your Lambda function needs and limit the execution role to these permissions. Be familiar with Lambda quotas. Payload size, file descriptors, and NTMP space are often overlooked when determining the runtime resource limits. Delete Lambda functions that you are no longer using. By doing so, the unused functions won't needlessly count against your deployment package size limit. If you are using Amazon Simple Queue Service as an event source, make sure the value of the function expected invocation time does not exceed the visibility timeout value on the queue. This applies both to create function and update function configuration. In case of create function, AWS Lambda will fail the function creation process, and in case of update configuration, it could result in duplicate invocations of the function. And lastly, monitor your AWS Lambda as it relates to security best practices by using AWS Security Hub. So Security Hub uses security controls to evaluate resource configurations and security standards to help you comply with various compliance frameworks. Security best practice number 3 is implement managed services. So implement services that manage resources such as Amazon Relational Database Service, AWS Lambda, and Amazon Elastic Container to reduce your security maintenance tasks as part of the shared responsibility model. So for example, Amazon RDS helps you set up, operate, and scale a relational database, automates administration tasks such as hardware, provisioning, database setup, patching, and backups. This means you have more free time to focus on securing your application in other ways described in AWS well-architected framework. Lambda lets you run code without provisioning or managing servers, so you only need to focus on the connectivity, invocation, and security at the code level, not the infrastructure or operating system. Today, more workloads are using AWS Lambda to achieve scalability, performance, and cost efficiency without managing the underlying infrastructure. These workloads scale to thousands of concurrent requests per second, making AWS Lambda one of the many important services that is offered by AWS today. AWS Lambda is used by hundreds of thousands of AWS customers to serve trillions of requests every month. A broad variety of customers from media and entertainment to financial services and other regulated industries are taking notice of AWS Lambda. These customers are more interested in decreasing time to market, optimizing costs, and improving agility by focusing on what they do best, running their business. Lambda has become the obvious choice for mission-critical applications in many industries. The managed runtime environment model of AWS Lambda intentionally hides many implementation details from the user, making some of the most existing best practices for cloud security irrelevant and creating the need for new best practices. So AWS Lambda is an event-driven serverless compute service that extends other AWS services with custom logic, or creates other backend services that operate with scale, performance, and security. Lambda can automatically run code in response to multiple events, such as HTTP requests through Amazon API Gateway, modifications to objects in Amazon S3 buckets, table updates in Amazon DynamoDB, and state transitions in AWS Step Functions. You can also run code directly from any web or mobile app. Lambda runs code on a highly available compute infrastructure and performs all of the administration of the underlying platform, including server and operating system maintenance, capacity provisioning, and automatic scaling, patching, code monitoring, and logging. With Lambda, you can just upload your code and configure when to invoke it. Lambda takes care of everything else required to run your code with high availability. Lambda integrates with many other AWS services and enables you to create serverless applications or backend services ranging from periodically triggered simple automation tasks to fully fledged microservice applications. Lambda can also be configured to access resources within your Amazon virtual private cloud and by extension your on-premises resources. You can easily wrap up Lambda with a strong security posture using AWS Identity and Access Management and other techniques discussed earlier. To maintain a high level of security and auditing and meet your compliance needs, benefits of Lambda customers who want to unleash the creativity and speed of their development organizations without compromising their IT team's ability to provide a scalable, cost-effective, and manageable infrastructure. AWS Lambda lets them trade operational complexity for agility and better pricing without compromising on scale and reliability. Lambda offers many benefits, including the following. So, no service to manage Lambda runs your code on highly available fault-tolerant infrastructure spread across multiple availability zones in a single region, seamlessly deploying code and providing all of the administration, maintenance, and patches of the infrastructure. Lambda also provides built-in login and monitoring, including integration with Amazon CloudWatch, CloudWatch Logs, and AWS CloudTrail. Continuous scaling. Lambda precisely manages scaling of your functions or application by running event-triggered code in parallel and processing each event individually. Subsequent metering with AWS Lambda, you are charged for every 100 milliseconds of your code executes and the number of times your code is triggered. You pay for consistent throughput or execution duration instead of by server unit. Increases innovation. Lambda frees up your programming resources by taking over the infrastructure management, allowing them to focus more innovation and development of the business. Lambda also enables you to use functions with a pre-trained machine learning models to inject artificial intelligence into applications easily. A single API request can classify images, analyze videos, convert speech to text, and perform natural language processing models. And also, as you can see, there is a number of AWS management services that can help you reduce the burden and reduce the management of actual resources. And you can provision things like change management, provisioning and configuration management, event and incident management, security management, patch management, continuity management, and reporting. So as you can see, most of the resources on the right can be part of the AWS managed services, and this can greatly reduce the burden on security. The fourth best practice allows you to automate compute protection. So as you can see in the flow below, we can monitor our resources using AWS services, systems, and applications. We can detect specific events and alarms or incoming notifications, and then we can respond with a triggered action, such as remediation action, create a compensating control, or outgoing notification to other tools and services. So to automate your protective compute mechanisms, including vulnerability management, reduction in attack surface, and management of resources, the automation will help you invest time in securing other aspects of your workload and reduce the risk of human error. So it's important to automate configuration management, enforce and validate secure configurations automatically by using configuration management service or tools. So you can automate patching of AWS Elastic Cloud Compute instances using AWS Systems Manager Patch Manager. Automates the process of patching managed instances with both security related and other types of updates. You can use Patch Manager to apply patches for both operating systems and system applications. So using AWS Patching Manager, you can obviously monitor and detect security misconfigurations or vulnerabilities, and then create an event of how you're going to respond to those specific vulnerabilities, whether it's automatically deploying patches, or we can manually review and create specific workloads, how you're going to test those patches and then deploy them. It's also very important to implement intrusion detection and prevention. So you can implement intrusion detection and prevention tools to monitor and stop malicious activity on instances. Also, you can consider AWS partner solutions. There is hundreds of industry-leading products that are equivalent, identical to, or integrate with the existing controls in your on-premise environments. These products complement the existing AWS services to allow you to deploy a comprehensive security architecture and a more seamless experience across your cloud and on-premise environments. So as you can see, creating and connecting a number of workflows, we can automate specific programs such as vulnerability management, reduction in attack surface, as well as management of resources. So we can automatically, for example, if we detect specific vulnerabilities or specific misconfigurations in our network flow, in our firewall rules, we can automatically create remediation tasks, how we remove or adjust specific rules, how we block specific IP addresses that relates to firewalls and security groups. So there's a lot of work that can be done to automate compute protection. Best practice number 5 is all about enabling people to perform actions at a distance. We obviously know that nowadays most of the organizations allow their people to either work on a hybrid setup or remotely. So how we can allow our people to perform actions at a distance. So removing the ability for interactive access reduces the risk of human error and the potential for manual configuration or management. So for example, use a change management workflow to deploy Amazon EC2 instances using infrastructure as code, then manage the EC2 instances using tools such as AWS Systems Manager instead of allowing direct access or through a bastion host. So these are essentially tools to removing human error and direct access to machines for day-to-day management, which normally can lead to a human error. So AWS Systems Manager can automate a variety of maintenance and deployment tasks using features including automation workflows, playbooks, and the run command. AWS CloudFormation stacks build from pipelines and can automate your infrastructure deployment and management tasks without using AWS Management Console or APIs directly. Using run command, a capacity of AWS Systems Manager, you can remotely and securely manage the configuration of your managed nodes. A managed node is any Amazon Elastic Compute Cloud instance or non-EC2 machine in your hybrid and multi-cloud environment that has been configured for Systems Manager. Run command allows you to automate common administrative tasks and perform one-time configuration changes at scale. You can use run command from AWS Management Console, the AWS command line interface, as well as AWS tools for Windows PowerShell or the AWS SDKs. Run command is offered at no additional cost, so you can use run command with no cost. Administrators can use run command to install or bootstrap applications, build a deployment pipeline, capture log files when an instance is removed from an auto-scaling group, join instances to a Windows domain, and many, many more useful applications. The last but not least, security practice number 6 is all about validating software integrity. So implement mechanisms, for example code signing, to validate that the software, code and libraries used in the workload are from trusted sources and have not been tampered with. So for example, you should verify the code signing certificate of binaries and scripts to confirm the author and ensure it has not been tampered with since created by the author. So AWS Signer can help ensure the trust and integrity of your code by centrally managing the code. Signing lifecycle, including signing certification and public and private keys. You can learn how to use advanced patterns and best practices for code signing with AWS Lambda. Additionally, a checksum of software that you download compared to that of the checksum from the provider can help ensure it has not been tampered with. Recent security-related incidents indicate the need for a security software supply chain to protect software products, also referred to as code, during the development, build, distribution, and maintenance phases. Of particular concern is provisioning and updating software that plays a critical role in platform security. A wide range of software products, including firmware, operating systems, mobile applications, and application container images, must be distributed and updated in a secure and automatic way to prevent forgery and tampering. So as an effective and common method of protecting software is to apply a digital signature to the code. Digitally signing code provides both data integrity to prove that the code was not modified and the source authentication to identify who was in control of the code at the time it was signed. When the recipient verifies the signature, he is assured that the code came from the source that signed it and that it has not been modified in transit. So the developer is the entity responsible for writing, building, and/or submitting the code that will be signed. This entity maintains a secure development environment, including the source code repository, and will submit the code to the signer after it's been completed the organization's software development and testing processes. The signer is the entity responsible for managing the keys to sign the software. The role may be performed by the same organization that developed or built the software, or by an independent party in a position to vouch for the source of the code. The signer generates the code signing private public key pair on a device that is sufficiently protected, as the security of this process relies upon the protection of the private keys. In many cases, the signer then provides the public key to a certification authority through a certificate signing request. The CA will confirm the signer's identity and provide a signed certificate that ties the signer to the provided public key. Anyone can use the public key associated with this certificate to validate the authenticity and integrity of the code signed with this key pair. If no CA is used, the public key must instead be distributed using a trusted out-of-bound mechanism. The signer ensures through technical and procedural controls that only authorized code is signed. When code is submitted by developers for signing, the signer verifies their identities, and their authority to request a signature. The signer might also take additional steps to verify the code is trustworthy. Ultimately, 2 or more trusted agents of the code signing system may be needed to approve the request and generate a digital signature. In some cases, the signed code may also be provided to a timestamp authority to indicate when the code was signed. The verifier is responsible for validating the signatures on a signed code. The verifier may be a software component provided by the same developer as the signed code, for example, for a signed firmware update, or it may be a shared component provided by the platform, i.e. operating system. So AWS Signer is a fully managed code signing services to ensure the trust and integrity of your code. Organizations validate code against a digital signature to confirm that the code is unaltered and from a trusted publisher. With AWS Signer, your security administrators have a single place to define your signing environment, including what AWS identity and access management role can sign the code and in what regions. AWS Signer manages the code, signing certificate, public and private keys, and enables central management of the code signing lifecycle. You can also integrate with CloudTrail, helps you track who's generating code signatures and meet your compliance requirements. So that's a very important task. If you are in an organization that creates and ships code, how you can validate the integrity of the code that you are creating. So hope you guys learned something from these best practices, how to secure your compute resources. We're going to cover some of the other security pillars in our introduction into cloud security in the next videos. So please like and subscribe, and thank you for your time.